So hello, my name is Karthik Deshpande, and today I will be teaching a very important algorithm which is used to find out all the prime numbers between 1 and n. It is known as the Sieve's algorithm. So first let's look at the unoptimized approach. So this is our main function. Here we will be creating an array list to store all the primes, and this is our function to get the primes. This is our first function to get the primes. In this function we simply iterate from 2 to n. We do not consider 1 because 1 is not a prime, we know that. So from 2 to n we iterate over all the numbers, and for every I we calculate the factors of I. To calculate the factors of I, we use the very simple brute force approach, in which we traverse over all the numbers from 2 to I and check if the number is divisible by any of its with any of the numbers. If it is divisible, then we increase the count of factors. At the end, if the number of factors is not equal to 0, then we know that it is a prime and we add it to the list. Sorry, if the factors is 0, then we add it to the list. So this is brute force approach consisting of 2 for loops from I to n and from j to I. It is order of n square and the space complexity is order of 1. But a small optimization which could be made here is that we do not, to find all the factors of a number, we do not need to traverse completely till I. We can simply traverse till the square root of I. If we do not find any factors till square root of I, it is guaranteed that there won't be any factors beyond that also. So this is a minor optimization here, which gives us the time complexity as n square root of n and space complexity as 1. So this is the code. Let's try it once. So we can see all the primes from 1 till 1000 are being printed correctly from this brute force approach. Here we passed 1000, hence the primes till 1000 are being printed. The time complexity, we went from n square to square root of n, but can we do better? So yes, the answer is we can do better by using trade-off between space and time. If we use little more space, which is order of n, then we can reduce the complexity to approximately n. So this is the new function. This is main. In this list we will store the primes till 1000 and then we will print the primes. So let me first explain the algorithm. This is the Sieve's algorithm. What we do in this algorithm is, first we create a Boolean is prime array. Boolean array. I am creating an array of length n plus 1 so that I can access all the numbers from 1 till n, and initially all the elements in the array we will mark them as true. I will tell the reason. So is prime of I is equal to true. So when we created the array had all the false. By default it is false in Java. Now we have made all the values true. That is, initially we are saying that let us assume that all the values from 1, let's consider our n to be 18. So let us assume that all values from 1 till 18 are prime, and hence we have marked it as true. What we will do is we will iterate from 2 because we know that 0 and 1 are not primes. So this would be false from beginning itself. And now what we will do is we iterate on a number and we check whether it is a prime or not. If it is a prime, then we know that all the multiples of that number will not be prime. This thing is for sure. So we go to all the multiples of 2 and we mark them as false. Let me just copy paste the line, it would be faster. Okay, so we go to all the multiples of 2 and mark them as false, because 2 is surely a factor of them and hence they cannot be prime. Hence we are doing this thing. Okay, now let's move on to the next number, which is 3. We see that 3 is true, which means 3 is a prime. So now we go to all the multiples of 3 and mark them as false. So 6 is already false, we will mark 9 as false. 12 is already false, we will mark 15 as false, and again 18 is already false. Now we go to 4. 4 is already false, so definitely all the multiples of 4 will also be false, that is they again won't be prime, so no need to check for 4. We will go to 5. We see that 5 is true, so we go to all the multiples of 5, which is 10. 10 is already false. Then 15 is already false, and that's all we can go. Now again, one interesting thing is that we do not need to check further, because all the numbers, if we are standing at any position I, then it's okay if we start checking after I square, because all the numbers before that will already be marked. So from here we can simply tell the answer. All the numbers which are 2 are 2, 3, 5, 7, 11, 13 and 17. So these are our prime numbers from 1 till 18. Now let's code it out and check whether our algorithm works fine with the code or not. So first we have initialized our is prime with true, and now for int I equal to 2, I less than equal to n I plus plus. If I is prime, then in that case add I to our list of primes, and for int j equal to, so like I said, we can start checking directly from the square of I, and j less than equal to n, and we have to check for every multiple of I, hence we add I to it, and we do is prime of j equal to false. And yeah, that's our complete function. Let's try running it. So java c dsa 2.java, there is an error, boolean cannot be dereferenced. Okay, sorry, this would be is prime of length. Compiled successfully. Now let's check it, and the answer which we came from dry run, here we can see that it matches. 2, 3, 7, 11, 13 and 17 are the primes between 1 and 18. Now what would be the time complexity? So this for loop is running from 2 till n, so the time complexity becomes, so from here we know that the time complexity is at least order of n, because here it is one loop and inside there is another for loop also, but this is not an order n loop. This loop, the time complexity contributed by this loop would be log of n. It would be even lesser than log of n, which, So this we can approximately say it is equal to order of n, which is a great optimization over our previous approaches. But there is a trade-off of space complexity, which is order of n, because we created a Boolean is prime array to store whether a number is prime or not. So this was the method of sieves. I hope you understood it from my lecture. Thank you for watching.